Okay, right. Hello everyone. We're moving on to Trig Identities in the next exciting episode of Matric Corona Maths. Some key ideas, which are very similar to what you did in grade 11, when you're doing identities. First of all, just start off by splitting the page. So you have your left-hand side, draw a line, the right-hand side. Sometimes you'll work with one side, okay, just one side. Most times you'll work with both sides and show that the left-hand side is equal to the right-hand side. The difference from grade 11 is now you're going to be using double angle formula, okay, as well as compound angle formula. We'll talk through those just now. With the double angle formula, if there's theta, you've got to keep looking between the two sides. If the one side only has theta but there's a double angle thrown in, okay, you've first got to get rid of those double angles. For sine 2 theta, there's only one choice. You're going to make it into 2 sine theta. Cos theta, remember, these are all on your formula sheet. For cos 2 theta, you've got a choice of those three. Okay. And I just made a note here. I said choose which one you're going to use according to what's happening on the other side. So let's say I had cos 2 theta, and in the denominator on the other side I've only got sines. Okay, then I would change the denominator to 1 minus 2 sine squared theta. Say in the numerator you only had cos, then I change to that. Occasionally use the mixed one, usually it's one of those two. You've got to, with identities, keep looking at both sides to try to get them to be the same. Alright? There's always if there's a question which involves just tan, only tans in the sum, then generally you leave it as tan, but for most of them there's a tan and there's some sine and coses. You can always pick up a mark by rewriting tan as sine over cos. And then your square identity, sine squared plus cos squared is 1. We also often change 1 minus cos squared into sine squared and 1 minus sine squared into cos squared. Right, carrying on. Steps for tools for solving identities. Okay, don't forget you can also use compound angle formula. See your info sheet. You've got to be working with your information sheet at all times, my guys. If you're not, you're being a bit of a dumbass. Okay, then sometimes you're going to have to simplify, and the main thing you have to do in terms of simplifying is when you're adding and subtracting fractions, get an LCD. Now, there are other things obviously, but this is so. If I had 1 over cos 3 theta plus 3 over sine theta, well, your LCD is going to be cos theta sine theta, and then remember you say, what do I times the bottom by to get to there? I times it by sine theta, so I must times the top by sine theta, so I get sine theta there. Here I times the bottom by cos theta, so I must times the top by cos theta, so that would be your LCD. Just an example of how you get an LCD. Okay, carrying on with your summary of hints for identities. Also, you've got to look to be able to factorize, and if you can't see the pattern, go to the side of your page and let cos theta equal to A or sine theta is equal to B, and then factorize. Okay, so for example, if you're told to factorize cos squared A minus sine squared A, you can go straight to the answer if you see it, but if you don't, say, okay, well, if I had A squared minus B squared or X squared minus Y squared, what did that factorize to? Factorize to X minus Y, X plus Y. So using that logic, cos squared A minus sine squared A is going to factorize to cos A minus sine A times cos A plus sine A. So this is what you do on the side of your page. Okay. Likewise, if you had sine squared A plus 2 sine A plus 1, well, if I had x squared, so whenever there's an x, I'm replacing it with sine A. Sine A is equal to x, so I'd have sine squared A would be x squared plus 2 sine A would be x, so plus 2x plus 1. Well, if I asked you to factorize that, that's x plus 1 times x plus 1. Okay, in other words, it's x plus 1 all squared. In other words, sine squared A plus 2 sine A plus 1 is going to be sine A plus 1 all squared. And the last thing which you sometimes have to do, and it's usually in a case like this, where if you've got 1 plus, that just means, I'll just put a squiggle, 1 plus something sine A cos A plus sine squared A or cos squared A. In other words, there's this term sine A cos A, there's a number, and there's a sine squared A or cos squared A. You couldn't do anything with that at that stage. So in that instance, what can help is you make 1 is equal to sine squared A plus cos squared A. So you replace that 1 with sine squared A plus cos squared A. Then you go add like terms, and then you would factorize. So those are your basic hints, okay, for identities. Okay, and the main hint is practice a lot. Kidoki. Right, we're moving on to the textbook. Okay, page 4, Mindful Math, exercise 4.7, page 149. Okay, so go to that, please. And we're going to be doing A, 1, 3, 5, 7, and 9, and C. And A1 says required to prove cos theta plus sine theta squared is equal to 1 plus sine 2 theta. So your first step, split the page. There's your left hand side. Your left hand side is cos theta plus sine theta squared. Your right hand side is 1 plus sine 2 theta. So single angles, double angles. Okay, pick up the easy mark, get rid of the double angles because you want to get everything to single angles, right? So 1 plus, well, go to your formula sheet. What's sine 2 theta? Well, there's only one option for that. 1 plus sine 2 theta is equal to 1 plus 2 sine theta cos theta. There's nothing more I can do with that. Okay, right, on this side, okay, remember you're using this logic that if you've got a plus b squared, Morgan Brown, what's a plus b squared? Sorry? Indeed it is. A squared plus 2ab plus b squared. What a fine human being you are, Morgan Brown. Okay, and I end up with that over there. So, using that logic, cos theta plus sine theta all squared will be equal to cos squared theta times the two together and times by 2. So plus 2 sine theta cos theta, okay, plus sine squared theta, okay, and Nicole Thomas, okay, what's cos squared theta plus sine squared theta? It's equal to 1, fantastic, so I get 1 plus 2 sine theta cos theta. And what do you know? Voila, the left hand side and the right hand side are the same thing, so you finish it off and say, Ms. Marker or Mr. Marker, I have now proved that the left hand side is equal to the right hand side, and I am amazing. Right, how's it put? We are now going to do exercise 4.7, and we are doing question question A number 3. Okay, give it a try, and then you can have a look at the solution. Okay, so you've got asked to prove that cos 4 theta alpha minus sine 4 alpha is cos 2 alpha. So, Daniela, okay, tell us please, if you had a to the 4 minus b to the 4, okay, let's go to the side of the bottom of your page here. How could you factorize that? Okay, indeed, all the way from the south, you are quite right. Okay, so, and could you do some more with that? Okay, well, let's just have a look. Okay, so we'll worry about that later. So cos to the 4 alpha minus sine to the 4 alpha, using that logic over there, we can rewrite this as cos squared alpha minus sine squared alpha times cos squared alpha plus sine squared alpha. Right? So Daniela, something should be yelling at you. Indeed it does. That thing is equal to 1. So the left hand side is equal to cos squared alpha minus sine squared alpha. And you should be doing a little whoop for joy. Why? Because cos 2 alpha, if you look at your formula sheet, okay, keep looking between the sides, is equal to cos squared alpha minus sine squared alpha. And therefore you can finish it off and say therefore left hand side is equal to right hand side. Well done, Daniela. Send my regards to the south. Ni hao. Right, we are doing number 5 now of exercise 4.7. Give it a go first and then you can have a look here. And let's have Chinese girl number 1 doing this. So we've got sine theta plus sine 2 theta over 1 plus cos theta plus cos 2 theta. And we've got it, that's on the left hand side, and on the right hand side we've got tan theta. Right. So there's, if that was just tan thetas, I might be able to leave that, but you may as well pick up this mark now, get some runs on the board. So Chinese girl number 1, what's that going to be? Fantastic, that's why you're number 1. Sine theta over cos theta. Right. So now, Chinese girl number 2, okay, that's a guaranteed mark, okay, because I'm going to, and see I've got some double angles here, so the next thing I want to do is get rid of the double angles, okay, because everything else is single angles, okay. So first we're going to get rid of the double angles. So sine 2 theta is a bit of a gimme, and Chinese girl number 2, what did you get? Well, if you can read off your formula sheet, you'll be able to do that. So I don't think you're that smart just by doing that. But, okay, but now is the fun part. In the denominator here, okay, I've got a cos 2 theta. And the problem is cos 2 theta, okay, there are always three different options that you have. So any one of the options would be right and you'd pick up a mark. But you can save a lot of time by making an educated guess which one's going to help you the most. And the way I do it is I look at this side. On this side, what's in the denominator? It's just causes. So I want to keep it as just causes in the denominator over here. So what's that going to become? Okay, so you could have a choice of cos squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 cos squared theta minus 1. And because I've got cos theta in the bottom here, I want to keep cos squared theta in the bottom there. So I'm going to have 1 plus cos theta plus 2 cos squared theta minus 1. Okay, and now, well, you can factorize the top and the bottom because the 1 minus 1 disappears. Okay, so you're left with cos theta plus 2 cos squared theta there. So the common factor is cos theta, and over here, the common factor is sine theta. Just one thing, I'm never going to look at this and say, oh, I know how to do that straight away. It's just, you've got to back yourself, follow the process. Okay, you can't just see the answers. Okay, so if I take out from the top, there are 2 terms. Let's go back to Chinese girl number 1. Okay, right, and what's the common factor there? Oh, this is why. Indeed it is sine theta. Okay, so if you take out sine theta, okay, to get what do you have to times sine theta by to get back to there? By 1. And to get back to there, well, plus 2 cos theta, right? And at the bottom, remember these have gone now. Okay, the 1 and the negative 1. Okay, so what's the common factor here? It is cos theta. And once again, you're left with 1 plus 2 cos theta, which is fantastic news. Why? Because those 2 can cancel out, and you're left with sine theta over cos theta. And if you keep glancing over your shoulder, just like you do when you're playing soccer, to see if somebody's coming, you should keep glancing over your shoulder with identities, and you've got the left-hand side is equal to right-hand side. And well done to the Chinese. Okay. High five yourself. Righty, good day, Husna. Husna, you're going to do the sum for me. I hope your brain is working, even though you're pretty hungry right now. And you could be eating something delicious, which is what most of us have just done. Alas for you, tough times. Right, so Husna, okay, 2 over sine 2a. Okay, well, the left-hand side is tan a plus cos a over sine a. The right-hand side is 2 over sine 2a. You've got to prove that they are equal to each other. So, pick up, there's one double angle here, the rest are single angles, so let's get rid of the double angle, pick up the obvious mark, and sine 2a, if you can read, which you can, is going to become 2 sine a cos a. So I've just changed sine 2a into 2 sine a cos a, and the 2's cancel, so the right-hand side simplifies to 1 over sine a cos a. So that is what I'm going to try to work towards is with the left-hand side, get it equal to 1 over sine a cos a. Right, so Husna, okay, tell me please, what would you do here? Oh, indeed you are correct. You may be a villain, but your math is fine. And you're going to get sine a over cos a plus cos a over sine a. Right. So Husna, how do we add fractions? Indeed we do. A common denominator, which is going to be what? Oh, fantastic. Sine a cos a. Right. And then you say to yourself, what did I times the bottom by to get to there? I times it by sine a. So sine a times sine a is sine squared a. What did I times the bottom by there? By cos a. So cos a, whatever you do to the bottom, you do the same thing to the top. So you get cos A times cos A, which is cos squared A, and sine squared A plus cos squared A is 1. So I'm left with 1 over sine A cos A, and voila, Husna has got it right. The left-hand side is equal to the right-hand side. Well done, Husna. Okay, hope you have a delicious meal post-sunset. Right, good day, sharers. We will be doing together now exercise 4.7, page 149, number 9. And we were talking like this because we are in our best St. John's Panama hats. So, not really a St. John's hat, but a typical attire worn by a parental from the neck of the woods. Right, so the question is, we have got sine 4 theta minus sine 2 theta over cos 4 theta plus cos 2 theta. And let's start. And on the right hand side we have tan theta. So let's start with Sarah Jacobson, who had the best sheesh on the WhatsApp group the other day, the master understatement. Okay, so Sarah Jacobson, tan theta, let's pick up that mark. Yes, easy peasy, lemon squeezy. It's sine theta over cos theta, and you've got a mark, Sarah. Well done. Right, now on the left hand side, it's a bit ugly. We've got 4 thetas and 2 thetas. So my suggestion would be to first get rid of the 4 thetas and get those in terms of 2 thetas. So sine, remember, sine, let's call it 2a, is 2 sine a cos a. In other words, sine of double an angle is 2 sine half of an angle cos of an angle. So Sarah Murray, okay, sine 4 theta. How could I write that? Okay, as 2 theta. Well, sine of an angle, okay, is 2 sine half of whatever that angle is, just like a is half of 2a. So in this case it will be 2 sine 2 theta cos 2 theta. Okay, so that is sine 4 theta. Okay, minus sine 2 theta. Remember, with sine of a double angle, there's not much choice. So with cos 4 theta, okay, again, look at this side. Okay, at the bottom there's only coses. So just like cos 2a could be written as 2 cos squared a minus 1, I'm going to use that logic for cos 4 theta, okay, because I'm picking the cos option because there's a cos at the bottom here, so I want to keep cos at the bottom over there. That's what I'm saying. Keep glancing from left to right. So Sarah Jacobson, cos 4, using this logic, what will cos 4 theta become? Indeed, it'll become 2 cos squared, what's half of 4 theta? It is 2 theta. Okay, so cos 4 theta becomes 2 cos squared 2 theta minus 1. That's cos 4 theta. Okay, and I'm just going to leave cos 2 theta for now. Okay, so now the temptation is to rush and to try to get all your double angles to single angles, but if you do that, it's going to get phenomenally long and ugly. So press pause. This is a tricky sum, and so let's try to sort it out in terms of 2 theta before I rush to get rid of those double angles. Quite simply because there's just too many things there. If you had to change that, it's going to be a mission. Too many double angles to change to single angles. So there must be another trick. So I want to try to factorize the numerator. Who are we on? Sarah Jacobson. What's the common factor at the top? Indeed, it is sine 2 theta. Which just goes to show raw lasagna can power a brain. So I get sine 2 theta. What I have to times by to get back to the first term? 2 cos 2 theta minus 1. Okay. Now I've got to factorize that. Okay, so it might become more apparent if you rearrange it as 2 cos squared 2 theta plus cos 2 theta minus 1, and hopefully that gives you a bit of an idea, okay, that we're working with a trinomial. Okay, and if you can't see how to factorize that, let every cos theta be equal to whatever, x. So we'll have, the pattern would be 2x squared, okay, because it's 2 cos squared 2 theta. I'm letting cos 2 theta be x, plus x minus 1. And that shouldn't evoke terror in you because it factorizes to 2x, x, okay, and then we've got 2x, x, to get to plus 1, that's going to have to be plus 1 over there, and minus 1 always times our trinomials in check. 2x squared plus 2x minus x is plus x minus 1, so that's right. Okay, so using that pattern, okay, what does that factorize to? Well, we're going to have sine, let's leave the top as it is, and at the bottom, if I follow that pattern, it's going to be 2x minus 1, in other words 2 cos 2 theta minus 1, and over here it's going to be cos 2 theta plus 1, okay, which is lovely indeed, because you've got two things times together at the top and the bottom, which means you can cancel that with that, so you're left with sine 2 theta over cos 2 theta plus 1. Now once again, I've got no choice for sine 2 theta. Okay, I'm going to go, where is it? It is here. Okay, so, okay, if I carry on over here, I'm going to have, those have cancelled. Okay, that's cancelled with that. So sine 2 theta, now I've got to get them to single angles. You see, by doing that, I start changing a whole lot of double angles. Sine 2 theta becomes 2 sine theta cos theta. Okay, no choice there. Now, Sarah Murray, cos 2 theta. Okay, you've got three choices. What you're going to use? Well, there's cos at the bottom on the right-hand side, so let's keep it as cos. So cos 2 theta, we're going to write as 2 cos squared theta minus 1. That's cos 2 theta over there. Then I've got a plus 1. So I'm left with 2 sine theta cos theta over 2 cos squared theta. And what happens now? Well, the 2's cancels. This cos cancels with one of the coses over there. Okay, so I end up with sine theta over cos theta. Sharers, well done, because you have shown me that the left-hand side is equal to the right-hand side. Fantastic stuff. Good day. Right, we shall be having Kwakwa and Alero doing the sum for us. So, it's a bit of a silly example to have chosen, but too late. I'm too tired to go back and change it because it's very similar to the last one. So, you should be able to nail it. I've got to prove, first of all, that sine 2 alpha is equal to 1 plus 2 cos alpha. Okay, sine 2 alpha over that is equal to tan alpha, right? So, Kwakwa, pick up the easy mark. So, what's tan alpha? Oh, fantastic. Tan alpha is sine alpha over cos alpha. Right, so now, okay, sine 2 alpha, Alero, yes, easy peasy, becomes 2 sine alpha cos alpha. And now, let's go back to Kwakwa. Cos 2 alpha, what's you going to make that? Well, I've got cos at the bottom here, I want to keep cos at the bottom, so let's go for 2 cos squared alpha minus 1. So I'm left with, simplified, 2 sine alpha cos alpha over 2 cos squared alpha. Okay, and then the 2's cancel, cos alpha will cancel with that one, so I end up with sine alpha over cos alpha. Right, so therefore, Lera and Kwakwa have successfully proved that the left-hand side is equal to the right-hand side. Okay. Okay, and our last one, question C2. Okay, and Shema and Muslafo, let's do this. We proved in C1 that sine 2 alpha is equal to 1 plus cos 2 alpha. Sine 2 alpha over 1 plus cos 2 alpha is equal to tan alpha. It says hence, which means you've got to go use that. Okay, I would have said hence evaluate without a calculator tan 75, but just the hence actually is enough because it's saying to you, hence means you've got to use that. Okay, hence doesn't say hence otherwise. So you're using that, go work out tan 75, no calculator. Right. So, using this logic, tan, what we prove is what, Shema? It's that tan of an angle is equal to sine of 2 times an angle plus 1 of cos 2 times that angle. So, Shema, what's tan of 75 going to be? It's going to be sine of good 2 times 75, because your initial angle was 75, so wherever you see alpha you replace it with 75, over 1 plus cos 2 times alpha, which is 75. Essentially, you're subbing in alpha for 75 degrees. So, Mhlako, what do we end up with? Good. Sine 150 over 1 plus cos of 150. And the question is evaluate that without a calculator. So, Mhlako, yes, I know you're going to use reduction formula and special angles. And so we get that. And sine 180 minus 30, which quadrant you in for 180 minus, all students talk crap. That's going to become, I'm going to go up here, 180 minus, sine is positive, so it's sine 30 over 1 plus, cos of 180 minus is going to be 1 plus negative cos 30. Okay, so I get sine 30, which is equal to, using your special angles diagram, at 30 degrees y is 1. So I'm going to get a half over 1, plus and a minus make a minus. So 1 minus cos 30 is going to be 1 minus root 3 over 2. Okay, and if I carry on down there, instead of this line, I'm going to write the divide sign. So it's going to be a half divided by, you can go cheat and use your calculator at this stage, just pretend you're very clever. And I'm going to get a common denominator here, so it's going to be divided by 2 minus root 3 over 2, which becomes a half times 2 over 2 minus root 3. The 2's cancel, and I'm left with 1 over 2 minus root 3. Okay? Lovely stuff. Well done, me, and to my little helpers. Okay, and that is that actually. So the last thing left to do is to bid you adieu, Matrix. I adieu you, and please go look at the notes you're given and go do your optional homework. Okay, I hope you have a fantastic day. Stay safe and stay sane. Arrivederci.